Hello Year 6 and welcome to your first chemistry session in your Year 6 to 7 Science Bridget unit. Now today's session we're going to look at the three states of matter, so looking at solids, liquids and gases. This is something that I'm sure you've covered during your time at your primary school. So our learning objectives for this session are for you first of all to be able to name the three states of matter, so to be able to identify that materials can either be classified as a solid, a liquid or a gas. We also want you to be able to state the different properties of solids, liquids and gases. Now, a property of a substance is just a way of saying how it behaves. So can you squash that material? Does it have a fixed volume or does the volume change? Does it have a fixed shape or does the shape change? Can it flow? Does that material move? That's what we mean by properties. Now, some of you also will start to be able to describe the arrangement of the particles in solids, liquids and gases. And then as you move into Year 7, we'll build on this work and you'll be able to use the arrangements of particles in solids, liquids and gases to explain the different properties. Now then, Year 6, let's get started. So as you can see, there's a series of questions on this slide, and there is also a link in blue to a YouTube video. So what you're going to do is click on this link and watch the video. This will then allow you to answer these questions. Now it's up to you how you do this. You can either copy down these questions and the table first, and then answer the questions and complete the table as you're watching the video, or you can choose to challenge yourselves and watch the video first and then work through these questions. Now, however way you want to do it is entirely up to you. So the questions are, what is matter made of? So when we talk about matter, I just want you to think about the material. So what is everything made of? What are the three states of matter? I want you to name the states of matter represented in the three diagrams on the board. You then have a table to copy down, and it's talking about the properties, so the characteristics of solids, liquids and gases. So the first one says particles are held closely together. If you think that is describing a property of a solid, now I'm not saying that it is, but if it is, you will then put a tick in the solid. If you think it is also describing a gas, again, not saying this is the correct answer, you'll put a tick in the gas column. It then says particles can flow. Now in brackets I've used the term move. So I want you to think when we talk about particles flowing, we are sort of linking it to moving. However, at Key Stage 3 and Key Stage 4, we don't say particles can move, we use the term flow. Then says states of matter have a definite shape and volume. So definite just means fixed or that it doesn't change. So the shape doesn't change and the volume doesn't change. Now the term volume is just referring to the amount of 3D space that the object or the state of matter takes up. It then says state of matter has no definite shape or volume. Then says state of matter has a definite volume but no definite shape. It has strong forces of attraction between the particles. When we're talking about the term attraction, we just mean that pull between the particles, that they're attracted to each other. Now, you'll notice there's also 3 rows that are in red. Now, these are the challenge questions, and you can do these if you choose. Now, these are questions that aren't necessarily answered in the video. However, what you learn in the video, you should be able to apply that knowledge to answer these questions. So it says here particles are arranged in a regular pattern, random arrangement of particles, and particles vibrate around fixed positions. Now when we're talking about arrangement of particles, we just mean where the particles are placed or how they're positioned. So if you think about you and your class, I could say to you, right, Year 6, can you please arrange yourself boy, girl, boy, girl? I could say, can you please arrange yourselves in groups of 5? Or arrange yourselves from the tallest to the shortest. It's just how you would be placed in that classroom. So, watch the video, answer these questions, and I'll see you soon. So let's look in more detail at the three states of matter, and we're going to start with the solid. So as you can see in the diagram, the particles in a solid are close together. There's no space between the particles because there's a strong force of attraction between each particle holding them together. We describe their arrangement as a regular pattern. They're in neat little rows. Now the particles, although you can't see it in this diagram, are actually vibrating. Stand up and keep your feet on the floor close together. And I'd like you just to move from side to side quickly. I would like you to vibrate around a fixed position, which is the position of your feet on the floor. That is what particles do. So you're now acting like the particle in a solid, where you're not moving around each other, but you are vibrating around a fixed position. Now, as you can see, the particles in the solid, because they're close together, we can't squash them, we can't compress them, and they have a fixed shape. They also have a fixed volume and they don't flow. Now, we compare that to the particles in a liquid. The particles in a liquid are still close together, although there are some gaps between the particles, but they're still close together. However, we'd describe their arrangement as random. They're not in the nice uniform rows, they're not in the regular pattern as a solid. Now, the particles in a liquid can move around each other. So imagine there's you and any brothers or sisters in your house, and you're not moving away from each other, you're slightly touching, but you're just running round and around each other. That's the arrangement of particles in a liquid. Now, particles in a liquid, they can flow, but they do not have a fixed shape. If you get a glass of water and you pour it into a beaker, it will take the shape of the beaker. If you then take that same glass of water but pour it into ice cube trays, now we have got some Lego ice cube trays, very cool at our house, and they will take, that water will take the shape or whatever shape of Lego tray I put it in. You can also see from that diagram that the particles in a liquid, because they're not as close together, because that force of attraction between the particles is not as strong, they can flow. So you know that liquids can flow. When you turn on your tap, your water will flow out of that tap. Now, let's start looking at a gas. Now, straight away when we look at the gas, we can see a massive difference between the arrangement of particles. Now, the particles are far apart. There's very, very, very weak forces of attraction between these particles. And these particles have a lot of energy, a lot more than liquids and a lot more than solids, meaning they can move around quickly in all different directions. We like to use the word random. They move in random directions. So if you were to get up and you and your brothers and sisters or your parents or your animals, your dogs, went to the park and you all ran around in that space, you'd be acting like a particle in a gas. Now, as you can see, for these particles in the gas, because they're a very weak force of attraction between the particles, you could squash them together, which means they don't have a fixed volume, and they will take the space or the shape of whatever container you place them in. So let's look back at the questions you were asked. As we go through this, can you please correct your answers? So, matter is made out of particles, and it is how these particles are arranged that determine the state of matter that the object is. The three states of matter are solids, liquids and gases, and like we've already described, the first one is solid, arranged in regular pattern, particles all close together. Second one is a liquid, where the particles are arranged in a random arrangement but they're still close together. And the third one is a gas. Particles are far apart and arranged in a random arrangement. So if we go through these properties and look if they're referring to a solid, liquid and gas. Particles held closely together are both solids and liquids, but we know that they're slightly further apart in a liquid than a solid. Particles can flow refers to a liquid and a gas. Now we generally use the word flow as opposed to move. Right, a state of matter that has a definite shape and volume, so a fixed shape and volume, is a solid. A state of matter that has no definite shape or volume is a gas. And a state of matter that has a definite volume but no definite shape is a liquid. Right, there are strong force of attraction between particles in a solid. Now, again, some of you might have pushed on to these slightly harder, more challenging questions in red. Particles arranged in a regular pattern is a solid. Random arrangement of particles is a liquid and a gas. And then the particles vibrating around fixed positions, solids. Well done for any one of those that you have got correct. So what we're going to do now is we're going to have a quick little recap of everything we have looked at in today's session. So what you'll need to do is get 3 pieces of paper now. They can be scrap pieces of paper, and on one write solid, on one write liquid, and one write gas. I'm going to ask a series of questions, and you need to see if you can hold up the correct cards. If you think I'm describing a solid, hold up solid. Now the idea is that you'll get the answer before I've said it. Good luck. Particles are arranged in a regular pattern. Solid. Well done if you got it right. There's a definite volume but no fixed shape. What am I describing? Well done if you said liquid. Right, this state of matter doesn't flow. What am I describing? Excellent if you said solid. There is a very weak force of attraction between particles. What am I describing? Well done if you said gas. If there's a random arrangement of particles, what am I describing? Liquid and gases. Excellent work if you held both answers up. Now Orla is holding a substance, and in this substance there are weak force of attraction between the particles, but the particles are close together. What is she holding? Excellent if you said liquid. Particles move quickly in all directions. Gas. Well done. There's a strong force of attraction between the particles. Well done if you said solid. Now, something that we talked about, but it wasn't in the video. It can be easily compressed. Excellent if you said gas. Now, I want you to think about, so there's a little challenge. Why do you think a gas can be compressed when a solid even can't? Have a think about it. Write your answer down on a scrap piece of paper or on your piece of paper that you're going to show us. Why do you think gases can be squashed? So the particles in the gas can be squashed, whereas the particles in a solid can't. Right, here's the answer. Don't worry if you didn't get this. This is a challenge question. So the gases can be compressed easily because there's lots of free space between the particles. And when you squash those particles in, you can push these particles closer together because there's space for them to move into. Well done for today's session, Year 6. And I will see you soon for session 2. So well done Year 6 on completing your first chemistry lesson. So now you can name the 3 states of matter, you can state the different properties of the solids, liquids and gases, and some of you can describe the arrangements of particles in solids, liquids and gases. Well done for working so hard. See you soon for our next session.